whenever we have, there are certain basic steps. You know, first thing is that you, whenever you have these, to you have to mark forces, the forces on each body, each body, considering each body separately. Mark, mark forces. Then, second step, make equations uh, of motion. No, equations of force. That means resultant force is equal to ma. Then find uh, make equations. So then find a and forces, which could be tension also here, simultaneously solving equation. Simultaneously solving equations. Or once you know the acceleration, you can find the velocity. So this, because you know the distance also here. So these are the steps. One thing clear. First, we have to find the forces. Forces, this force is mg here. Hmm? This force is mg here. Any other force? Tension here. Any other force? Tension here. Tension is always away from the body. So arrow I have drawn away. Mg is toward the center I have drawn here. This will have two components. Mg cos theta here and mg sin theta here. Here it will also be mg sin theta here. 30 here. And this will be mg cos theta here. Now the mg cos 30 will get a reaction from it will be balanced by the reaction from the inclined pulley, inclined plane. This also will have balanced mg cos 60 here, 45 here will be balanced. This, so what are the forces? This you can ignore now because I have resolved it, so I don't need this anymore. So I can just remove. So this you have to draw to the teacher. Otherwise, the teacher will give you 2 marks here. Look, this this was without the friction. The equation was, this was mg 50 na sine, and tension was here, and this was, and we found this was bigger. So we found this was bigger. So we said mg sine 30 um, was is I need space. So the equation we wrote was for B, for B, mg sine 30 is the force acting down. So mg sine 30 is the force acting down. T is the force acting up, minus T, and mg sine 30 is greater. So that is equal to ma. This, what does this equation mean? It means the resultant force. The resultant force. Why? One force is acting downwards. This is acting downwards. This is acting upwards. So resultant is the difference in these two. That is equal to m. Acha, for A, it was T. It is, this is going down. This is going up. So T is greater. T is greater. So we say T minus mg sine 45 is equal to ma. Now m in each case is different and sine is different. So we took m here, would have been 0. No, 1.2, 1.2 and whatever, 1.2, and here it would have been. But I'm not talking of with the values. What I'm saying is this is mg sine 30 and minus this. Now he says I introduce friction. He says I introduce friction. So what has changed? Friction is mu r. Friction, what is friction? He says mu is given. Find the value of mu, sorry. And he says both are rough now. So initially they were smooth. So we don't have to worry, but now we have to think of friction. Friction will come, friction is moving down, so friction will come up. Here it is going up, so friction will be here. What's the friction? Friction is, so now the equation change. There are three forces. I said, what is friction is mu r. What is r? R is mg cos theta. That I told you. So friction is mu into r or mu into mg cos theta. So now there is another force. So there are three forces. So there were only two forces. Now there are three forces. One force is acting here. Two forces are acting here, tension and friction. So now it will be mg sine 30 minus t minus mu mg cos 30. This is equal to ma. And here tension is acting up, friction is acting down. Mg sine theta is acting now. So here it will be T minus mg sine theta 45. Friction is also acting down. So minus mu mg sine cos 45 is equal to ma. So now the equations have changed. We have got two different equations. And he's asking me to find the value of mu. So again you can add, again the tension is same, again it will go. But this time you can have an unknown mu. This is 0 0.8 in this is 0.8, and here it is 0.8, here it is 1.2, this is 1.2, and this is 1.2. Acceleration is uh, here this is equilibrium, so acceleration is 0. Okay, this is 0, the equation, this is 0. So that means uh, you'll get a equation in mu. Okay, there is the resultant force are, is causing zero acceleration. Na? He said equilibrium, right? So the same thing you can just put ma 0. है ना? If it's not equilibrium, then it becomes ma. Otherwise, it becomes 0. So let me show you the answer. So first he finds mu cos 45. Okay, then he gets this where uh, where fa is too very confusing. FA and FB, this method is so stupid. This is, anyway, this is the same thing. I'll show you how. My equation comes out to be, um, he's saying T, T, this equation is T is equal to mg sine 45 plus mu mg cos 45. So he's saying that this is T is this plus FA. FA is the friction. So that's, and the other equation he gives is T is equal to mg sine 30 minus F. This T goes to the other side. This also goes plus F is equal to Tmg sine theta. So what does he do here? He says 1.8 for A. What was the equation? No, this is for, I was finding it for B. Yeah, 1.2. So F plus T or mg minus F. So in one it will be plus F, in one it will be minus F. Yeah, it is plus here in this, and in case this is minus. In B, in terms of B, it is minus, and these are the frictions. The mu, this is uh, this mu R is done. Friction is this is the reaction, and he multiplies it by mu to get two frictions, and he puts these frictions there. But he's boy, they're the same thing I'm doing. Is trying to. You understood or no? Hmm? I have got. I will just the tensions. If I add, it will go away, na, and I'll get an equation in terms. If you this minus this is equal to this plus this, and this goes to the other side. The only unknown is mu, and you can calculate. T to goes away. T cancels.